Thank you. Good morning to all of you.
Yeah, good morning.
Before we started, I was a little worried about extending this program. If it is 1.5 hour duration, as originally planned, it would eat into your lunchtime. But then I also quickly realized that most of you will be listening more than showing your face or your participation. So if you feel hungry, my suggestion is you side by side eat. Do not go hungry. Good. So what I have here, usually, this is a little funny. I have examined my own self in the past when people ask me distance between 2 points in the city or in two towns or two cities. Typical reaction from me would be to talk in terms of number of hours. Someone asked me how what is the distance between Chennai to Bangalore. Instead of saying 350 kilometers, I would say 6 hours. This is how typically I react. Similarly, when I prepare slides for a presentation, for a 45 minutes presentation, I usually select only 20 slides. 1 hour, 30 slides, 1.5 hours, typically 40 slides. But today I have taken the liberty of making some 50 slides. The only hope I have is you're all learned people already teaching. So this is like training the trainers or teaching the faculty. Therefore, some of the slides which I have, I will move on fairly quickly, unlike presenting to an industry audience or a student audience. Today I will take the liberty of going a little on a little higher pace. My hope is that in case you want to, I'm sure the organizers will make these slides available to you. I will share as PPT also. As and when you have some questions, doubts, my suggestion is please get back or dwell deep into it, read some of the suggested standards or documents so that all of us become familiar with the topics. So with these two forewords, I would like to go into the presentation. As you all know, India, you heard Dr. Nagesh Kumar in the first session. India has a very unenviable target of having to reduce 33 to 35% of its GDP intensity on emission on a 2005 value. 2005 is the benchmark. By 2030, we are supposed to achieve this result. You must have heard after this Paris Agreement, Trump exited the commitments for USA of 26 to 28%, whereas India have time and again recommitted themselves to meeting these targets, and they are working on this. If you know, to meet these targets, what are the abatement opportunities available for India? Energy efficiency gives you the highest potential of 51%, followed by renewables, biofuels, nuclear, and CCS. Now, this efficiency per se is what we are discussing in this 1 week of your SSTP, and I have chosen the motor and motor systems, which are, in other words, the end-use energy efficiency in a plant. So, if you look at the Government of India's intervention, 1,75,000 megawatt has been targeted by 2022. This came sometime in 2018, 17-18. 2022, the target was to achieve 100,000 megawatt of new renewable energy solar, another 60,000 megawatt through wind, 10,000 megawatt through biomass, and 5,000 through small hydro. So that will sum up to 1,75,000 megawatt. We all know that in the post-independent era, we became an industrialized nation, and we went on to build almost every of our power generating stations post the independence. When we got independence, the installed capacity of power generation was just 1362 megawatt, 1362. Today, the power requirement of Chennai during June, July, these summer months is about 2,500 megawatt. That of the National Capital Region, NCR, which includes Delhi and nearby cities, which are clubbed into one, is almost 11,000 megawatt. So today's capacity requirement will give you a frightening reality that in 1947, when we got independence, we almost had nothing. 1362 is nothing for the entire country as a whole. So from there, we have built something like 3,50,000 megawatt now, and we have to build another 3,50,000 megawatt or slightly more by 2030, when we will become an urbanized economy. Today we have 5 metro cities in the country. 2030 estimate is we will have 16 metro cities. So you know, the metro cities are cities where you have a large urban population coming and living, eking out a living, working, educating children, entertainment, and so on and so forth. So the growth projected for the country by year 2030, when almost 75–80% of our population will live in urban cities, is about approximately 7,50,000 megawatt. So those new generation capacities will have to be necessarily renewable in order to prevent depletion of further earth resources like oil or coal and so on. So with these in mind, knowing that the energy efficiency offers the handsome potential of almost 51% of our country's energy efficiency measures, we will proceed with the end-use energy efficiency applications like operated by motors and motor-driven systems. For today's agenda, I have divided this into 3. We will look at the motors themselves, look at the motor-driven system, and look at the speed change, which offers an excellent opportunity for energy optimization and therefore energy conservation and energy efficiencies. So these are the 3 areas in which we will have some presentations today. The complete system intervention could offer as high as 50% reduction in energy consumption. Knowing that the complete system can offer as much as 50% gives the weightage required for us to address each one of these 3 systems. The scope lies, as Professor Dr. Nagesh Kumar said, lies in best practices and system components. So as divided as motor systems and end users, you can take a look. High efficiency motors is an intervention which the government has already enacted. The repair maintenance is in the hands of the industries, but best policy is required for repair and maintenance or replacement per se. And similarly, best practices are required at every stage of maintenance or management of motors. That goes for the motor system as well, where we look at variable speed drives as an option for optimizing, controllers in terms of valves and dampers if it is a fan, the transmission elements like pumps, couplings, belt pulley drives, gearboxes, and so on, and the best practices for this system as a whole. The end-use applications involves pumps, fans, compressors, refrigerations, which constitute to almost 2/3 of the total population of motor-driven systems. So therefore, knowing the torque profile characteristics and how energy efficiency can be analyzed, established, and achieved is an important approach available to industries. There again, we need to know what is best practices available for maintaining all our systems properly. As you know, India has a huge power generation capacity already built for although the per capita consumption of electrical energy for our population is much lower than most of the developed countries. You all know that we are developing and we are trying to meet the country's requirements across the country, including small villages. And in this, you will find that industries account for almost 46% of the energy consumed after taking out the agriculture, commercial, domestic, and others. So therefore, industries become very important when it comes to energy efficiency measures being addressed and practiced. And within the industries, as you can see here, almost 69% of the energy is fed through electric motors. Now, there are some misunderstandings on electric motors being responsible for energy. They are responsible for the power that is fed. energy is consumed at the hands of the driven machine. So that is importantly the reason why we are looking at it as a system rather than motors alone. So electric motors account for nearly 69% of the energy consumed in the industry, followed by electrolysis process, induction heating, and others. Others will include nowadays the IT loads also, like printers, communication equipments, computers, and so on. And lighting is a major contributor to the others column here. So therefore, motor becomes very important. This 70 is average for industries, but if you look at some industries like textile, almost 92% will be motors only. Textile does not have, textile in the sense the spinning mills do not have any thermal energy being used in their process. So therefore, it will be totally electrical. So the average 70 will be much higher there. There are some industries where the average will be lower than the national average, where thermal energy is extensively being used. So motors are important. And when we look at motors, we always persuade the industry to look at the life cycle cost of a motor, or that for that matter, even the driven equipments. The energy spent for running these motors. If the motors run, there is productivity. So the production efficiency is important. Once the production efficiency is established, the running efficiency of these motors gives rise to a life cycle cost approach, where almost 98% of its lifestyle cost is spent in energy, not in procuring or in installing and commissioning or maintaining. So therefore, it's very important to look at motor as well as the motor system by its energy life cycle cost, and then give importance to maintenance, replacement, repair, and other areas of energy efficiency measures. Most of you will know that we have energy efficiency through motor system, and we have three technologies in front of us. One is a very age-old technology, more than 135 years old, called induction motors. We now have, in the last 30-40 years, two more new technologies for motors: permanent magnet synchronous motors, switched reluctance synchronous motors. These are the three basic technologies available for large industrial motors. What you hear about BLDC or easy motors and so on and so forth are limited applications for buildings and some control monitoring, cooling, and things like that. So if you look at induction motors are the most matured, like I said, in terms of the years. So therefore, on a scale of 1 to 3, they have the highest rank of 3, most matured, followed by the permanent magnet synchronous motors, and then the switched reluctance synchronous motors. Switched reluctance synchronous motors are fairly new. One commentary on the two new technologies is that as we are increasing the efficiency internationally, the standards for efficiency, we have now breached the IE4 efficiencies declared by the International Electrotechnical Commission. For IE4 or over IE4, we will be induction motors will be found wanting. We will be left with PM or SR motors as the future potentials. So therefore, anything like IE4 can be met through induction motors. It has been met, but some of the testing standards, they are falling behind. They are not able to meet the stringent testing standards now being proposed by the IEC for meeting IE4 efficiency levels. So therefore, my estimation is that the induction motors will stop with IE3 at best, and then for IE4, IE5, or even IE6 in the future, we will have to depend on these two new technologies. If you look here, high peak efficiency, again on a scale of 1 to 3, induction motors are offering only 1, which is the lowest in the scale. Permanent magnet motors will be 3, followed by switched reluctance motors, number 2. Because of the fact that the Chinese are trying to monopolize the permanent magnet rare earths available in the country, in the world, many leading manufacturers like Siemens, ABB, and others have shown a lot of interest in refining this technology, switched reluctance technology, so that in the future you will find motors are being offered both for manufacturing in India as well as for meeting some of the higher efficiencies like IE5, IE6, and so on. So this is just a commentary on the technologies available. This is again an information regarding what are the distribution of various types of motors in our country. One quick run through. We manufacture motor industries, registered motor industries manufacture around 60 lakhs motors, of which around 43 lakh motors are fractional horsepower motors which are used in appliances. So for the purpose of our today's discussion, we will ignore the FHP motors, but concentrate on the integral horsepower motors, which is approximately 14 to 15 lakhs of motors. Of these, we divide them into AC and DC motors. DC motors are cumbersome and they are slowly losing sheen. We find that these numbers are dwindling. This is for the year 15-16. After that, 4-5 years have gone by, records are available. This number is coming down and this number is going up. Therefore, AC motors will form the most important chunk of motors for industrial applications. And we know induction motor technology is available, matured, robust, maintainable, and fairly highly efficient. Like Dr. Nagesh Kumar said, the average efficiency of induction motor system is around 90%. Very low for small motors, fairly high, 96-97% for large motors. So the AC motors again are divided into four. Into HT, high tension motors, that is 3.3, 6.6 and 11 kV motors. We call it as medium voltage motors. Flame proof motors, again application specific, or industries which require flame proof or increased safety and other kinds of applications. Low tension slip ring motors is another area where the application is really losing sheen. People now have the choice of choosing squirrel cage with VFD to take care of the starting torque, intermittent high torque, and also the speed variation. For all these three reasons, we had slip ring motors. And the other reason why slip ring was popular was because of the low starting current. Now our grid system has become robust. It is no longer weak like it used to be in the 50s and 60s. And therefore, people can go for squirrel cage with VFDs and comfortably replace the slip ring motors. And slip ring motors are very, very cumbersome, difficult to maintain, and very inefficient. Their average efficiency could be as low as 70% because of the resistance that is left. And therefore, we are left with low tension squirrel cage motors, which are approximately 93% of the total population of motors. I have checked the market scenario published by the EMA for last 10 years, and I have confidence in telling you that more than 90% manufactured and sold and used in the market is squirrel cage TFC motors. And today's program will focus on the large majority of 90% and more of squirrel cage induction motors. One slide on typical applications. It is always useful to divide them into areas of applications for us to address them with its potential, with its difficulties, and the importance of these application areas. So as you can see here, there are three areas. Process machines are production machines which involve in shape change of the raw material to the finished goods. Utility machines, which are basically machines which do not directly involve in manufacturing, but they support and aid the manufacturing activities. And material handling or transport machines are machines which move material from one point to another point within the factory or outside the factory. So therefore, these three areas where motors are being used will become important for both selection, application, as well as in maintenance. And that is the reason why you have this slide found here. So some of you might be interested. You can expand. I have just used crusher, grinder, mixer, agitator, extruder. If you talk about textile, you will have blow room, carding, simplex, spinning, post spinning, and so on. If you look at paper industry, you will find various applications within the paper industry, and so on and so forth. Sugar, you'll have different applications. What is important for you to note, although we are not covering that particular point here, almost all of these process machines are constant torque application machines. Almost all of them are constant torque application. When it comes to utility machines, which aid the process of manufacturing, you have fans, pumps, blowers, compressors, vacuum pumps, and root blowers. All these, almost all these, are variable torque machines, which means that torque is proportional to square of the speed and power is proportional to cube of the speed. And this will form the basis for our discussions when we later discuss about the VFD in applications of motors. So utility machines, like I already said, almost 66% of the total installed capacities, and being variable torque in nature, will offer a fantastic foil for speed variations and optimization of energy, and therefore utility machines are very important. When it comes to material handling, very low percentage of machines are used for material handling, like cranes, hoist, conveyor, bucket elevator, escalator, lift, winches, and so on and so forth. And these are also constant torque applications, or in some cases they could be like in lathes, they could be constant inversely proportional, torque inversely proportional to speed relationship also. So we are not discussing these two areas when it comes to selection and application, but commentary on these three areas, splitting them into these three areas, will give us a better understanding about motor applications. Again, another commentary on how the motor is placed within a larger system and how does it get affected. Now, if you look at the motor, you find the motor is placed in an ambience which is affected by moisture, wind, snow, rain, depending on which part of the country we install. Chemicals prevailing within the plant, the atmosphere in the plant. The temperature extremes, hot, cold, medium temperatures, the airflow, vibration and noise, which are again ambient topics, quality of power supply, whether you are taking it from utility or from cogen. Cogen will have a much better quality of power supply in terms of voltage variations and the frequency variations, whereas utility will suffer from both these variations, and therefore they will have an impact on the they will have an impact on the performance of the motor. The controls used for the motors in like variable frequency drive or a soft starter or a starting, this will also decide how to size the motor, how to dimension the motor, and how to adapt the motor for applications involving these variations. Then the power transmission elements, we already discussed that. 1 or 2 slides are there. Basically commentaries on belting, direct connection, clutch, and gears. And then the mechanical systems, we already saw pumps, fans, compressors, their inertias. How does it impact the selection of the motor? How many number of starts and stops are involved? How it has an impact on the performance of the motor? Similarly, what about the mounting base? If you have common mounting base for both the driven machine as well as the motor, how the vibrations, alignments, and unbalance in the impellers affect the performance of the motor? And then the process itself, is it for flow, mixing, grinding, agitating, and so on and so forth. So placing a motor in a system surrounded by so many variables is a challenge in itself, and therefore we advocate a good proper product selection, application oriented product selection, sound installation maintenance, and also replacement policies to support the motors per se. So now we look at the system as a whole and what potential it offers for improving the system components and offering energy optimization or energy conservation or higher energy efficiency. So if you look at the motor which is placed within the larger system, very small saving is available. So what you can interfere and do with the motor per se can be very small. There will be no two opinion about it, because motors within themselves, their own self losses and their own selection procedure for protection, selection procedure for performance will offer a very small saving potential, followed by slightly better saving if you talk about the core motor system, which is motors, pumps, and speed change. That will give you a slightly better, larger energy saving potential. The largest energy saving potential will come through addressing the total motor system, which includes the transmission, gears, motors, piping, valve, damper, and so on and so forth. So this is how the whole opportunity is divided. You will find that in most of my presentations, I try to classify them into three areas: core system areas and total system areas. And this will follow till the end, so that we have a clarity about where to expect what and where not to spend a great deal of time. Like low hanging fruits, medium investments and medium paybacks, and large investments and large paybacks. So this is just a commentary on what is efficiency. Most of you will know it. Efficiency is basically reducing the losses, because we know output by input is efficiency, or in other words, output divided by output plus losses. So if we don't measure the output, we don't have a device to measure the output, but we have devices to measure the input, and therefore translating them into input quotient, we will find that input minus losses divided by input will give rise to efficiency. So if we have to reduce the input, we have to reduce the losses. So for achieving higher efficiency, the losses must be reduced. So this basic fundamental understanding is important when we address the end-use energy efficiency through motors and motor systems. Here is a slide which talks about various losses. You as faculty will know how it works. I have only given you one commentary, but it is probably new to you that we are segregating these losses into percentages. We have taken a 4-pole typically as an example. 20 to 25% will be the iron losses or core losses. Approximately 34% will be the stator copper losses. About 21% will be the rotor copper losses. Friction windage losses, which also constitute to your fixed losses, is about 8 to 14%. And the stray losses marked here in red box used to be 4 to 5%, but we were assuming, if you are aware of IS 4889, which is the standard for testing of motors earlier, loss separation method or loss segregation method, used to consider 0.5% as the stray loss across board, whether it is a 0.37 kilowatt or a 370 kilowatt. The assumption used to be 0.5% of the output power of the motor will be the stray loss, which is not correct, and which is what gave rise to our common international efficiency standard now. I have a slide as a commentary on that also, so we can take a look at that as we progress. So if you remember, we are talking about the motor per se, and within the motor, what impact it has on the selection. One single slide. I'm not going to completely take you through the process of selection, whereas selection of motors by itself would be a 4-hour session, a workshop. We are not looking at it today. We are looking at only the indications of what could possibly help you size the motor properly, or what some OEM could have missed while selecting the motors. Now, variation in supply voltage and frequency gives rise to sizing of the motors. We call it as a derating factor, and there are also some operating factors here. Just take a look. Typically, motors are suitable for 10% voltage and variation in voltage, 5% variation in frequency, or combined plus or minus 10%. For example, if you have 10% variation utilized with voltage, you cannot utilize any variation in frequency. That means the total 10% will be entirely voltage variation. Suppose you have a 6% variation in voltage, but your frequency variation can be 4%. Combined effect can be 10%. This is what is the meaning of this 10%. And if you ask in any part of the country, today it is not the case, but it used to be the case in most part of the countries, in rural areas, the voltage variation could be very high, and people used to ask for plus 10, minus 15. If you ask for a plus 10 or minus 15, then the motor has to be derated to 90%. A 100 HP motor will be 90 HP only. So you have to load the motor or select the motor accordingly for the purpose of installation. Similarly, ambient temperature. Between 30 to 50%, you can utilize the motor for its 100% of the capacity. Wherever the ambient temperature increases beyond 50, like 55, then you need to derate the motor to 95. Now, do not do an arithmetic progression by saying that 60 degree will be 90%, 65 degree will be 85%, which is wrong. Because once we talk about higher temperature, atmospheric temperature, More than 55 is not an ambient temperature. More than 55 could be a site condition. In such cases, we'll have to specifically design a motor, including care for grease, because grease melts and flows. The bearing temperature is 115 degrees centigrade. So if you have a total temperature rise which is exceeding the 115 degrees centigrade, then the question of using that motor in that application will be a problem. So in steel mills particularly, where the atmospheric temperature could be very high, please take help of a manufacturer and do proper selection of the motor. Similarly, the altitude of the location of the plant. Up to 1000 meters, you can use the motors for its 100% of the capacity available. As and when you increase, like Lonavala near Pune, or Ooty in Tamil Nadu, any hill stations if you are going, if you go to 3000, 3500 meters, you'll have to derate the motor output to 82%. If you don't do that, motor will get completely undersized, and therefore the motor failure could happen. Somebody is commenting that the audio is lost. Is it from my side or from his side or from the organizer side? Can you please kindly address this problem?
Might be from his sides.
We are getting. Yeah. You are getting me clearly. I am not lost. Okay, good. So we'll move on. Yeah, I'm moving on. So if you look at the voltage variations, we talked about plus or minus 10% variation. Absolute is permitted for the motor to deliver its rated power. But that is just about the only thing that the motor is capable of delivering. While the variations are applied either on the negative side or on the positive side. For example, here 0 is the rated voltage 415 in India. So if 415 volt is applied to the motor, you have various parameters to be considered. If it is 10% less, then your starting current will be less, your starting torque will be less, your power factor will be more, and your full load ampere will be more. Whereas when the voltage is higher, like it might happen in night times, if the rural and industrial feeders are clubbed together, during the night times you might find that the voltage has gone to 440, 445 and sometimes even 450. In such cases you will find the starting current will increase, the starting torque will increase, power factor will drop, and so on. But what is important for us to notice here, since it's a topic on energy efficiency, the efficiency curve of the motor will dip on either extremes. So in that sense, the energy efficiency is, for achieving energy efficiency, a voltage variation is undesirable. The efficiency is affected on either extremes of the voltage variation. This is mentioned in the first and original efficiency standard, IS 12615, 1989. India is the first country to specifically enact a standard for energy efficiency motor way back in 1989. The rest of the world came up from behind to develop their own international efficiency standards, and therefore we are now copying. So for you to understand, please read the foreword given in this standard, IS 12615, 1989, for you to understand that the voltage variation has an undesirable effect on the efficiency or energy conservation through the energy efficient motors. Similarly, what is the impact of voltage unbalance on the motors? So whenever the voltage unbalance exceeds 1%, the permitted limit as per IS 13529 is 1%. Whenever it exceeds that 1%, the motor gets derated. It has to be derated and applied. For example, for a 2%, it is approximately 5% duration. If it is 3%, 10% duration. So I have come across cases of 3 to 4% unbalance in voltage, purely system oriented, not load oriented. So from the grid, unbalanced voltage has been observed. So you are, as an auditing or a company which is involved in people who are involved in technology applications of motors, your first and foremost task will be to look at the voltage variation and the unbalance in voltage in any industrial site. Similarly, the efficiency also is impacted for every voltage percentage variation or unbalance. For example, 1% unbalance will reduce approximately 10% of 1% of the efficiency. 2% will reduce 2%, so it's exponential. So therefore, unbalance is also an undesirable component when it comes to operating an induction motor. Now the third and one single commentary on typical specifications of consultants or the contractors oversizing the motors. This is a big disease in our country. I have come across a number of consultant specifications where they deliberately put in difficulties for the motor manufacturers and the design engineers to necessarily select a higher output motor. For example, here we are discussing a case of a motor selection meeting the lock rotor withstand time, LRWT, lock rotor withstand time. See, typically they say lock rotor withstand time under hot condition at 75% and 100% voltages. They are giving provision for 25% drop in voltage. We discussed already about 10 or plus or minus 10% variation impacting the efficiency. But you see the consultant here, he says he wants lock rotor withstand time even at 75% of the voltage. He says it should be minimum 1.4 times the starting time of the corresponding voltage. So what happens here is a case example discussed here. You have ID fan 45 kilowatt with the GD square, that is the inertia of the fan at 250 kg meter square. The method of coupling is direct and the method of starting is let's say direct DOL. So the recommended motor by the fan manufacturer is one higher. Normally people recommend 45 kilowatt, they recommend 55 kilowatt so that there is cushion in the motor. So against the 55 kilowatt, just because the consultant had specified 1.4 times the starting current at the corresponding voltage, we go on simulating this motor selection, and both 100% and 75%, if we have to meet the consultant specification, we have to select a 110 kilowatt motor. Look at the sizing, oversizing, 55, 75, 90, 110. So 110 किलोवाट में जाकर के कंसल्टेंट का स्पेसिफिकेशन मीट होता है. This is something phenomenally criminal in oversizing of the motor. I'm just using this slide borrowed from one of my good friends who has conducted such kind of programs extensively. We use it for motor selection and what mistakes people make while selecting motors. So if you select a motor of 110 kilowatt for a 45 kilowatt mechanical BKW and then apply this motor for the application, you will find the efficiency has gone for a toss. So on one side we are talking about improving energy efficiency, on the other side we become victims of consultants giving improbable or impossible specifications for motors, resulting in motors getting oversized. So oversizing of motor is undesirable. While for a transformer, the best, most economical loading for a transformer distribution is 50 to 60%. For motors, the best loading will be between 60 to 80, 85%. So this is when the best efficiency is available and the motor performance can be more economical and more efficient. This is the topic of efficiency standard which I mentioned to you. So in 2008, IEC came with a standard called IEC 60034-30. This standard today is also prevalent, but it has come with another extension of 30-1 in 2014, where the growth into IE4 is also now included. So, but when it originally came in 2008, they started with IE1, IE2 and IE3 standards for the world as a whole. The need for international efficiency standard came because there was a quarrel between IEC world of manufacturers of motors and NEMA world of manufacturers of motors. You know about NEMA. NEMA is for North American countries and some South American countries also. So NEMA are predominantly 60 hertz motors, while IEC are predominantly 50 hertz motors. Australia, New Zealand, India, China, Pakistan. Most of Europe will be 400 volts 50 hertz or 415 volts 50 hertz. So these two are 50 and 60 hertz countries. They had quarrel on the last testing method and declaring on the nameplate. NEMA was always complaining that IEC motors are declared higher than actual on the nameplate efficiencies. So they came with a suggestion that there should be a common efficiency standard which should be found. And therefore they went ahead with converting EF of 2, EF of 1 onto IE1, IE2. NEMA had an equivalent of E-packed motors at that time equivalent to IE2. IE2 is called as high efficiency motor, standard efficiency motor is IE1. IE3 is called as premium efficiency motor. IE4 is now called as super premium or premium plus motors. So NEMA had IE3 at that time, NEMA premium, which is equivalent of IE3. Now NEMA premium plus is IE4. Now we are talking about IE5 also, super premium. So when this came, India was caught napping until 2011. The standard came in 2008. Testing standard came 1 year earlier. India in 2011 woke up to the reality that some of their motors were getting rejected from Europe. In 2011, after a few European dispatches, exports got rejected, Indian motor manufacturers quickly understood that IE2 is the minimum efficiency performance standard, MEPS, for Europe, effective 2011, June 2011. So they went and then pleaded with the Indian Standard Organization, BIS, through EMA, and then got IE2, IE3 as the efficiencies for our country. I have a commentary on most of the slides that I have here are commentaries, because I'm not here to educate you. I'm only here to basically inform you. Further learning, further understanding will come from deep readings and deep learnings. So use this as a file for searching for documents. You could approach me also, or you could go to the internet or go to authorities available in this country for discussing regarding impact of energy efficiency IE standards. So today we have IE2, IE3, IE4 in our country. We'll see in our next slide. This is IS 12615. I mentioned to you originally came in 1989. 2004 was the first revision. 2011 was the second revision. In 2018 we had the third revision. So with the third revision in India we have IE2, IE3, IE4. IE1 motors were never recognized in India because we did not want to become a dumping ground once most of the European countries left IE1 behind. So therefore we started with second gear IE2, IE3, IE4. So we now can meet IE2, IE3, IE4 in our country. And to introduce a good measure, the Government of India through Ministry of Commerce and Industries, Department of Industrial Promotions and Policies, DIPP, came with a GO, Gazette Order, saying effective 1st January 2018. Originally it was 1st October 2017. Some manufacturers wanted extension for implementing it, and therefore the government agreed to extend it to 1st January 2018. Effective 1st January 2018, in our country, no manufacturer should manufacture IE1. This is the policy, the GO Gazette Order. So this is happening largely. The next few slides will probably talk about what is happening with the energy efficiency standards and the motor manufacturers' compliance to it. This is just for your information, because you will be now taking up topics related to motors, motor efficiencies, and motor efficiency measures, and therefore this will be very useful to you. The scope document IS 12615 2018. There is a small commentary. I'll breezily run through it. IS 12615 2018 covers single speed 3-phase 50 Hz cage induction motors. So anything that falls outside this, they are not covered by the scope of the IS 12615. All are rated voltage less than 1000 volt, which is called as low tension motors, which could include 415 volts and 690 volts popularly. 690 is also available, and that is also a popular voltage range. Output is now expanded to 0.12 kilowatt to 1000 kilowatt. So more than 0.12 and less than 1000 kilowatt. All 2-pole, 4-pole, 6-pole, and 8 poles are now eligible for stamping as IE2, IE3, or IE4. It must meet frame size to output relation stipulated in IS 1231. This is a very important standard, IS 1231, for foot-mounted motors, 2223 for flange-mounted motors, which stipulate the boundary dimensions for fixing and operating the motors. No other standard in the world talks about the dimensions. There is no binding on the motor manufacturers to meet the efficiency standard as well as the frame size standard. Whereas in India, this standard specifies that motor manufacturers should conform to IS 1231 or 2223. This helps protecting the equipment selector, designer, engineer, as well as the person applicating in the industry to have the confidence that the previous motor, which is less efficient when replaced, will have the same identical dimensions, fixing dimensions as that of the new motor also. So this is a critical important topic for industries indulging in new motor purchases and replacements. The motors are rated for S1 duty continuous or S3 intermittent with 80% cyclic duration factor, CDF. This is as good as S1 motor, but S3 80% CDF very rarely people use. So these two are coming in this. Any other standards like S2 or S4, S5, S6, S7, S8 are not eligible to be stamped as IE2 or IE3 motors. Motors which are designed for operation on virtual, sinusoidal and balanced voltage conditions. If you remember the unbalance I talked about, standard scope says that the motor has to be having a balanced voltage condition as defined in 7.2.1 of IS/IEC 60034-1. This is the new Indian standard for motors, general standard. I have one slide on this. You can just take a look at it as we progress. And motors designed for an ambient temperature not exceeding 40 and altitude not exceeding 100. If you remember, I showed 50. Up to 50, you need not derate the motor. So motor manufacturers take advantage of this and they punch in their nameplate 50 degrees centigrade as the ambient. Although the standard says 40, motor manufacturers punch 50. Degree of protection IP44 or superior. Now IP55 is the degree of protection which manufacturers offer for TFC squirrel cage motors by default. So better than IP44. Method of cooling IC411, that is self-cooling fan. IS 6362 or IEC 60034-6 talks about various methods of cooling of the motors. IC411 is basically a fan fitted on the non-drive end of the motor, which offers cooling for motors, self-cooling. Similarly, service factor, which the compressor industry uses extensively, compressor manufacturers as OEMs, original equipment manufacturers, provide service factor 1.15 or 1.2, which is not as per the standard or scope of the standard IS 12615. So this is a commentary. If you read into each one of them, you will find new understandings as you progress. I'm just leaving it with the introduction to you. This is the scenario post the Gazette order by the Department of Industrial Policy and Promotions, DIPP, which I showed you as 1/1/2018. So in 2017, 87% of the motors manufactured and sold in the industries by EMA registered members, motor manufacturers, 87% was non-IE motors. Only 10%, although the standard in India came in 2011, if you recollect. IS 12615 2011 was the second revision, which brought IE2 and IE3. We came from behind, but we started with IE2 and IE3. So only 10% of the population until the legislation came was IE motors. 87% was non-IE. In 2018, people took time to react. The statistics says that 70% were still non-IE motors. This portion grew to 26, IE3 and IE4, IE2 and IE3. Whereas in 2019, this has become 5% because everybody complied with the Gazette order. So 83% of the motors are now IE motors, IE2, 11% IE3 and 1% is IE4, which is voluntary today. So you can understand that legislation drives in an opportunity for manufacturers also to improve their efficiency standards and the industries also to improve their demands. So this is one intervention which is going to prove very useful as we progress because high efficiencies are ushering in our country. Another commentary here, out of 430 manufacturers prior to the change in the standard, only 99 or 100 manufacturers have applied for and renewed the BIS license for manufacturing squirrel cage motors. So that is another aggregation that is happening. All and sundry are leaving, only important few and people who are confident about achieving these standards are remaining. So this aggregation is also important when it comes to not only industries, even manufacturers complying by the standards. So quickly, 4 or 5 standards. For those who are interested, you can note this down. And then Bureau of Indian Standard of late has decontrolled a number of standards. They are available without any payment freely. So if you were to click in the BIS site or in the Google, you will find some of the standards are already released for common consumption. So the standard IS 325 is no longer the standard for Indian motor manufacturers. IS/IEC 60034-1 2004 is the fundamental standard for rotating machines, rating and performance standards. So this is important. IS 325, if anybody is using, please educate them that it is gone. It is not. It is void and it is not to be used. Similarly, IS 12615 third revision 2018 is the standard for efficiency classes and performance specifications. So this is also an important standard today for industries. Industries cannot buy anything other than motors manufactured as per this standard. The efficiency testing standard. Earlier it used to be IS 4889. Today it is IS 15999 Part 2 Section 1, which got enacted in 2011. The corresponding IEC standard was enacted, like I said, IEC 60034-2-1 in 2007, followed by IEC 60034-30, which is the efficiency standard in 2008. We enacted IS 12615 in 2011, and in the same year we enacted the testing standard also by taking the reference to the standard by IEC 15999-2-1 2011. Another important document. IS 13555 is also an important document, which is a guide for selection and application of induction motors. I made just one or two suggestions only to you, that the selection application is one area where a lot of motors are misapplied, a lot of motors are wrongly selected and applied, and therefore to prevent that from happening, either through retrofits or through new project purchases, I request you to kindly take a look at this IS 13555. Very important document. It is a decontrolled document. It is available freely in the internet. From Google, you can download it. Spend some time learning it so that you can educate the industry with which you are interacting, or the students. See, another factor which motivates people like me to come and talk to you is because you are the people who are shaping the next generation of application engineers. And therefore, my interest is that you will be able to talk about the importance of these standards or the findings within the standards, so that they carry this and find themselves better while interacting with the industries. So the gap between the academy and industry can be narrowed if faculties like you can show more interest. You are doing a lot of preparations, I know, for every of your class. You are continuously educating yourself. You are the only people who read, who study, who understand continuously. Students don't do that. Even students who go on to read more, study more, there is one famous cliche which says that the more and more you study, the more and more you know about less and less things. So please reflect on this. Somebody who goes on to doing doctorate will be a doctorate in a special effect, or one particular effect, not the entire subject. So therefore, teachers like you, faculties like you are the ones who are always remaining in currency with the topic and the learning. And therefore, I appeal to you to read some of these standards, take time, understand them, and then either in the lab or in the class, educate and motivate the students to develop a scientific thinking and proceed further. So these are two important standards. Again, it's called as guide for selection of application guide for selection of cage induction motors for VFD. 90% of the people who are in the engineering industries do not know that there exists a standard like this, IS 15880 or IS 15881. When it comes to selection of motor and meeting the consultant specifications, it's very important to meet these two standards. Now, here is an effort by the Government of India under the Bureau of Energy Efficiency Policy Framework, NMEEP, EESL has come with a National Motor Replacement Program. National Motor Replacement Program looks at large-scale replacement of approximately 1.25 crore motors working in the Indian industries which are estimated to be below IE1 efficiency or even IE0 efficiencies, and therefore here is a potential pull effect through the government intervention where two schemes are available to industries to indulge in replacing old inefficient motors. So we are a part of this exercise. In fact, the roadmap for this exercise was also provided by us. Quick summary, quick commentary on how will you address the replacement. Instead of simply saying, I will replace all the existing motors which are older by 15 years or 20 years, you could also take it step by step, involve the industry to think and motivate themselves so that the management is able to make the investment. So the first step would be to prepare the inventory, prepare a list of motors available, classify them as small, medium, and large, and then also within them build a certain other informations which could be useful for them for both maintenance, retrofit, as well as replacement. Carry out an initial load survey to find out what is the load factor, what is the method of protection that is operating presently, whether it meets with the coordination charts, and so on and so forth. Then the third step would be to identify key motors based on the age, load factor, historical factors like rewind or repair, and the loading. The key motors can be identified and they can be used for the purpose of drawing a list of motors for replacement. Then comes load mapping. Load mapping gives you the opportunity to thoroughly study the application, suggest a few other areas. We discuss about driven machines, transmissions, VFD applications, and so on and so forth, and all that can be verified by doing a complete load mapping, which would be longer than, let's say, 30 minutes or 1 hour, to find out the typical loading, load cycling, and so on and so forth. So this is the 4 methods that we recommend for people who are involved in studying their existing inventory and using it for replacement. Just two topics on replacement. After that, we will go into the driven system. Small and medium sized motors, like I said, up to 30 kilowatt in our country are almost 95% of the total motors manufactured or applied in the industry. The large motors are only 5% or less than 5%. So when it comes to 95% of the population, as you know, Pareto principle, insignificant few and insignificant many and significant few. That's what the Pareto principle says. So the 95% of the population of the motors are approximately responsible for 60% of the power consumed or energy consumed in the industries. So therefore, what we can do is we can look at opportunities available for replacing based on what is called as a desktop audit. I will explain with one example. We take 2.2 kilowatt 4-pole as an example. If the existing motor is considered to be IE1, it could be even less than IE1. If it is considered to be IE1, as per standard, the efficiency is 79.7%. Whereas if you were to replace this motor with an IE3, same 4-pole, you will get 86.7%. Approximately, how much is it? 7%? Yes. Approximately 7% increase in efficiency or reduction in self losses. So therefore, small motors up to 30 kilowatt can be comfortably replaced based on efficiency increment in the motor itself. We don't have to look at the complete system. So this is one encouraging. This is called desktop audit, followed by what we do in industries, an audit for finding the efficiencies at site. Normally, the standards talk about testing the motors at the motor factory. It is also possible to estimate the efficiencies at site. I learned it way back in 1999-2000. It was codified into a project by the Bureau of Energy Efficiency. If you look for BW code project induction motor, you will find this document being detailedly explaining how to do this motor efficiency testing at site. They talked about the tools, they talk about the methods, and also they talk about various calculations involved in efficiency estimation. So as you can see here, I hope this small figures is visible to you. If you have to strain, I suggest please do a little bit of straining. I'll take you through this. 11 kilowatt 4-pole as an example for small medium. After small motors up to 30 kilowatt, we can also do an ample audit sample testing. So 11 kilowatt 4-pole, we can go on to test at various loads and then find out the efficiency and the load factor. So here is a motor 11 kilowatt 4-pole at 66% efficient load factor, gives only 85% efficiency, whereas nameplate efficiency was 90.1. So you can see approximately 4.5% efficiency increment is available because the old motor has become less efficient. Similarly, a 37 kilowatt 2-pole, 93% nameplate efficiency, not much of reduction efficiency at 68% load factor. So this motor therefore gives almost 45 months payback in the estimate, whereas this motor less than a year. So we also would like the academy and the people who are interested in energy auditing to look at opportunities available for estimating the energy efficiency at site. This is a new skill, this can help. So now we enter into the motor system. I hope I am not going to unduly exceed 12:47. I think I'll be able to finish it by about 1:10. So we already saw a motor kept in a large system. So this is another picture which talks about the system. So when we talk about the motor driven system, I wanted to use this slide, slightly different, but then the components are the same. Now, most of you would have seen this before. This is borrowed from somebody in the internet. So as you can see here, a 60 kilowatt motor to which a power is input has losses at various levels and in various components. Motor, for example, is 92% efficient, so 8% is a loss. Loss will be in the form of heat. So you are converting electrical energy into mechanical energy. The loss will be in the form of another energy. So therefore, this gives rise to the point that energy is neither cannot be produced, cannot be destroyed entirely. It can only be converted from one form to another form. So while we convert electrical into mechanical, there is another loss which is in the form of a heat. So this is the belt efficiency, which is approximately 99. If it's a new belt, it could be as low as 93, 94%. If it is an old worn-out belt, so efficiency loss, energy loss can happen because of the belt system. Bearing system 99.8%, reduction of 0.2 only, but poor bearing fitting maintenance, alignments, poor greasing, lubrication can also increase the losses within the bearing. The impeller losses is approximately 38%. 62% is the efficiency of the impeller system, such that, as you know, if you know the pressure and the flow, you'll be able to calculate the throughput from this fan system as 37.1 kilowatt. So what I'm trying to establish here is the fact that a 60 kilowatt input power, after accounting for losses in various stages, goes on to gives rise to only 37.1 kilowatt as the output equivalent power. So that you can see the efficiency of the system in cumulative is the product of all efficiencies, which gives rise to 56.4%. And this can be improved to 75-80% if we interfere with all the components and all the energy efficiency measures. So this is what is the scope for improving energy efficiency in the motor driven system. So we'll go on to see some cases. If you look at a pump, so you see here life cycle cost of a pump also says that almost energy cost accounts for 55% during its lifetime. About 8% is the first purchase cost. 8% is the installation cost, including the piping, base frames, and so on. And about 28% is the maintenance cost. So we have electrical, mechanical. This is a mechanical product. This also follows the same principle as a driven system, that the major chunk of its cost during its lifetime is spent on energy by running it and then the energy that it consumes. So therefore, it's very important not to look at this 8%, but to look at this 55% as potential available and keep improving this. Don't spend a lot of time on first purchase cost. This is the logic. Similarly, if you take a pump or a fan, typically in an industry, these are oversized when people select. There is, like I said, consultant specification, there is an engineering selection, there is a procurement activity which does some common selections, and there is a maintenance engineer who also wants his equipment to be loaded, I would not say poorly, but loaded less than the optimum, so that he will not have wear and tear and maintenance headaches. So this is how people behave. So if you look at the curve here on the right hand side, the x-axis is flow, y-axis is the pressure, and the efficiency curve is drawn in this axis, and you will find that the optimum or the best efficiency point occurs for a particular pressure and flow. And if the pump is oversized, the normal practice is to introduce a valve on the delivery side and reduce the flow. When you do a frictional reduction of flow, what will happen is, supposing you are bringing it to this point, what will happen is, at this point, your pressure will increase. It will not remain the same. So when the pressure increases, the efficiency drops further, and the equipment becomes inefficient, and it consumes more energy. Important is to address this point. Therefore, we have to select optimally and apply optimally, so that we do not lose because of oversizing. So I have a slide which also talks about the same topic, but when used with optimum RPM reduction with VFD, and how does it help us to improve the efficiency? We'll discuss that as we progress. So this is another slide where a typical power transmission element arrangement is redesigned in such a way that you have belt removed and the chain pulley sprocket removed. These were introduced originally at times when people wanted convenience in maintenance. Today, the reliability of these components has also gone up. So you are basically removing 96% inefficient or 4% loss and 7% loss because of the systems. And you directly couple the motor to a gearbox, and then the head drum is operated in a conveyor. And you find that the overall efficiency has gone up from 60% to about approximately 88%. So it's very, very critical to ensure that not only the motor, but we also look at the transmission elements in a drivetrain, and then eliminate what is inefficient and maintain high efficiency and achieve higher reductions in the overall consumption. Look at the flat belt versus a V belt, classical V belt. Nowadays, you also have cogged belts. Cogged belts are also more efficient than classic V belts. Classic V belts are old. So these kind of layouts, performance can be achieved, and the efficiencies can be higher. Savings can be as high as 5 to 12%, depending on various applications. These are some case studies which we have used here for the purpose of discussions. Similarly, 2 slides, again a commentary on maintenance world. You could include that in your scope of understanding. Not many engineering courses are conducted with these topics. If I am mistaken, please correct me. There is not much discussion on alignment, balancing, and so on. So alignment and balancings are very important parameters. Anywhere between 2 to 5% loss can be reduced by properly and optimally aligning and keeping the complete components balanced. Similarly, in the maintenance world, people use wrong tools, wrong methods of lubrications for grease, for fitting and removing of bearings and so on. So this topic, bearings in motors, I was mentioning to Dr. Sanjay Kote, could be an 8-hour topic. Bearings in motors, I learned in SKF for 4 days. And in 3 days, 3 nights, we could sleep barely for 3 hours. Such was the level of the work given to us, that we had to do a lot of reading, combined study and things like that during the night times. So I would say it was 4 days. That includes less than 3 hours of sleep in the nights. And the topic of bearings and motors was covered. So if I say 8 hours, we can talk about bearings, lubrications, fitting tools, and things like that. Please be please be acceptable. Don't be surprised. This is such a big topic, but I am restricting to just one slide because it's a token of introduction to basically all of you. So similarly, gear. When it comes to gear, you have worm, which is a age-old gear transmission made available in the industries. These can be removed with helical or bevel helical gears. If you can see here, the worm gear efficiencies are very poor, as low as 30 to 90%. So replacing with latest helical parallel axis or helical gears will give you very high efficiencies. So just a commentary on potential available for driven and drive transmission. Just thought I will, you must be having most of these already available. So maybe I'm showing, I also know it. So now we come into the motor driven system with VFD. Like I already said, almost 2/3 of the total potential available are variable torque, pumps, refrigeration compressors, compressor air compressors, and fan systems. These are used in the utility of the industries. 2/3, 65-66% of the applications are variable torque applications. And they offer excellent opportunity for energy optimization thanks to law of affinity. You must be knowing for all these variable torque machines or utility machines, RPM is proportional to flow. Square of the RPM is proportional to pressure. Cube of the RPM is proportional to power. So when we change the RPM, we not only optimally change the flow, we also change the pressure, and we also achieve a lot of energy saving. So when we talk about motor and motor system, there has to be a commentary, there has to be a lot of understanding on how to use these systems optimally using VFD or speed change. So therefore I have a few slides. I'll quickly finish this. So as you can see here, 30% of the total saving potential, it's not, don't say 100% is the energy reduction. Whatever energy reduction, if you consider that as 100% absolute, then 30% will come from speed control or electronic speed control. 10% will come from motor change. See, we already saw motor is only a small contributor by itself. 60% will come from optimization of the mechanical systems like pipes, couplings, valves, dampers, and so on and so forth. So this is very important for us to understand. So whenever you take a site and you want to discuss opportunities available in an existing system, two things are very important. One, the system is oversized inherently because of people's safety mentality, consultants, designers, and procurers. Two, they operate always using a frictional element like a valve or a damper, and these two are very inefficient for a system operation. And therefore, whenever you walk into an industry for energy auditing and proposing energy saving, then looking at it as a system and looking at it with VFD as a potential is very important. Now, again, I am talking about belt here because in my slide, excuse me. I spoke about speed change, not just as a transmission element, even as a a device which can help you drive your driven machine at the optimum speed. Because you remember, energy is consumed at the driven shaft. It is not at the motor shaft. Motor is only delivering what the load demands. So if the load is going to demand less RPM for its performance, you can go for a belt pulley, whereby you are reducing the speed. And this RPM is responsible for the energy consumption. So higher or lower will decide the flow rate and pressure, and also consequently the power. And that is the reason why I have put just one slide here for discussing about speed change and belt being a very important component. So as you can see here, a classical V belt the efficiency can be about 94% or slightly more when it is newly designed and installed. A narrow V-belt or a cocked V-belt can be 96%, 97% efficient. A timing belt or a flat belt can be 98 to 99% efficient. So not only the belt helps you to optimally size the driven load, and therefore the motor, it also helps if you are upgrading to different types of belts available in the market. One case study in which I was involved several years back, we had at that time EF of 1 motors. So as you can see, it must be before 2011 when the revision standard came. Ever since 2011, I have stopped discussing or promoting EF of 1. I have been on to EF, IE2 or IE3 only. Nowadays, I am on to IE4 also. So this is an industry in Chennai, which is a nylon fiber tire cord manufacturer. They had about approximately 15 machines, which were called as fiber extruders. And they had eddy current. Eddy current is again a magnetic clutch arrangement where you will have a speed matching depending on the extrusion and speed. So eddy currents are inherently inefficient drives. Their self losses are much higher. So we went for a VFD with the motor, new motor, and we did a study with one machine and then subsequently multiplied or duplicated to 15 machines. So huge saving was available. Although I have said here, client is planning. This is an old slide. Client has already replaced all the 15 machines with VFD and motors. So eddy current in that sense is undesirable. Wherever you find an eddy current drive, like in paper or in sugar also in some applications, I've come across or textile, some processing machines have eddy current. I don't know if I remember correctly, Dr. Sanjay Kot and myself, we discussed about an eddy current replacement. And I had given him some, at that time also I may have shared this slide. So eddy current is not a very good choice for speed optimization. Like slip ring is not a good optimal choice. Belt is not an optimal choice. Eddy current is not an optimal choice. VFD is a very good choice. Why? Because we'll take a look at this. If you see here, there are various methods used for a pump's optimal running. And I'm taking a case of a throttling. So what do you do? The original design is 10 by 10, flow and pressure 10 by 10. So the efficiency was laying in this curve. When the operating people decided that they do not require 10 flow, they require less flow, they throttled to 7. And when you throttle to 7, instead of coming down from 10, it is going up. You know the principle, right? If you take a hose and water the garden in your house, you will find that if your hose is not reaching a particular distance, you will always try to press the mouth of the hose such that you reduce the flow, but the pressure increases, right? It's the same principle. So you reduce the flow from 10 to 7, the pressure increases to 12.7, and therefore the new efficiency now lies here. Although in this graph it appears as a higher plane, the actual happening is the efficiency is dropped, but then still there is energy saving available. You see here, power now becomes 89% of original. If it was 100, it has become 89. That means 11% reduction in energy consumption. So in that sense, throttling helps in two. One, match the flow required for the process and also achieve a little bit of energy efficiency, 11%. Come diagonally across where we have discussed the same issue with a variable speed control, VFD. From 10, we take it down to 7. Because the speed is varied, the pressure does not increase. So it's only by square proportion. Instead of the earlier 10, it has now become 6.4. It remains in the same efficiency curve and offers you excellent opportunity to save energy, as much as 55% here. So this is what we have to understand. With VFD, friction losses are higher with the frictional dampers or valves, whereas optimum running of the RPM and also optimizing the pressure will help you to remain the same efficiency curve, maximum efficiency curve, and achieve a substantial reduction in energy. So this is the most important factor that we have to understand. Just one slide on the various types of characteristic load or torque characteristic of loads. As you can see here, this is called as torque inversely proportional to the speed. See, torque as the speed increases, reduces. Examples are winders, rotary cutting machines, and facing lathes. So initially when you start, there is a high torque required, but as you progress and increase the speed, you have achieved the proficiency in cutting and drilling, you will be able to increase the speed, but the power will remain constant throughout. So there is no energy saving in this kind of arrangement. So a product, a machine, a load with this characteristic will not offer you any energy saving opportunity by changing the speeds. If you look at torque constant, you can see here, this is speed and this is torque or power. If the torque remains constant, power will be proportional to the speed. So there is a marginal, if you reduce the torque required according to the machine, the power will reduce. So there is a marginal reduction in RPM. But again, this is not a load which is going to be unduly responsible for fantastic reduction in energy consumption because of VFD. So most of the production machines and transport machines, like I told you, are constant torque. You will find all the machines are in this range, like hoisting gear, belt conveyor, any process machine involving forming, rolling mills, planners, and these are all called as constant torque machines. Torque proportional to speed is also calendars with, you will find this in printing and processing industries and textile in your area. So where torque is increasing in proportion to the speed and power increases in square proportion to speed. So this is also a good opportunity for replacing some of the eddy current drives and brakes into VFDs. So you can try this. This is the largest 65%, like I told you, application areas where torque is proportional to square of the speed, like pumps, fans, and centrifuges, and power is therefore proportional to cube of the speed. So this offers an excellent opportunity to use VFD and achieve a higher energy saving. Now, while using VFD, 2-3 slides only, we'll quickly finish this. We'll be able to see, while using VFD and selecting motors, we will be compelled to understand a few things, like with VFD, the individual losses will only increase, they will not reduce. See, we are talking about energy saving, but what happens is the energy saving is available, but at some stages, energy consumption will increase. The motor will become less efficient, as you can see here. I will try and explain this. When the motor is applied, this thick line and dotted line. Thick line is the losses depending on the frequency to which you are operating. So supposing if it is 50%, there is not much of difference. But once you increase the frequency to 80 or 100 hertz, you will find that the losses are in square proportion to the frequency. So wherever you come across, nowadays you find in textile ring frames, 87 hertz motors are being used. So those are motors where you will have self losses of motors increasing, both at no load and at full load. So this is the backlog of, or the defect of the system. VFD will have additional joule losses, and that will reduce the efficiency of the motor. In fact, this has been now changed, but then IE3 with VFD will be IE2, IE2 with VFD will be IE1. So these are, some of the factors that affects the performance of the motor per se, but then this is accounted against an overall efficiency change or overall energy consumption reduction available through speed change. So this is one we have to understand. The second thing is we have to understand that VFD duty motors have to be VFD duty compliant. Many times we find that the existing non-VFD motors being used for VFDs. The reason is when you have a PWM supply, whether NEMA or IEC standard says that you should use dual coat winding wire and vacuum pressure impregnation. So these two are the critical, implement required for making the motor suitable for VFD. And even then, the temperature rise as per the standard IS 15880 clearly states that the temperature will be class F, but the rise will also be equal to class F. You might ask, Why it should be less than class F? See, insulation life depends on the temperature rise. So lower the insulation, lower the temperature rise, higher the insulation life. And therefore, to maintain, whether for constant torque or for variable torque, to maintain the temperature rise to F to B, we'll have to dimension the size of the motor. So this is a topic on which we can have a discussion if you want to expand, but I am only making a commentary. Each of my slide is a commentary. While talking about opportunity, I am also talking about challenges available. So this is the high efficiency motors. We have already seen this. I think I will be finishing with a case study where you are also in your area, a lot of cogen and power projects are there. Boiler feed water pump by somebody's design, people are buying high voltage motors, 3.3, 6.6 or 11 kV sometimes. So it is not required any longer. With the motors of LT 690 or 415 volt, providing a VFD is cheaper. So looking at it from the opportunity available for speed optimization and energy efficiency, I have just put this case study where in one sugar plant for boiler feed water pump, 280 kilowatt, 6.6 kV, we replaced with a 280 kilowatt 415 volt with VFD. So this is a case study available. And this is how the the profile of the power or energy was plotted based on the data that we captured. What is important for us to notice is that approximately 13.126 lakhs was the annual energy saving that was available. The difference between these two, 13 lakhs. The investment for 3 pumps was 17.3 motors was 17.62 lakhs. And the payback came in 1 year and 4 months, or typically in sugar industry in 2 crushing seasons. So this is a phenomenal saving. This is Kotari Sugars in Tamil Nadu. So anyone who wants to do a job, this is a big investment. You need to motivate the customer, show them this as a conviction, and then go on to develop your case example and then motivate them to make an investment. I think that is the last of my slides, and this is my slide where I have shared my LinkedIn profile, LinkedIn ID, Facebook ID, my mobile number and mail ID. My request is please ignore the mobile number because mobile number I normally don't entertain a lot of calls. Ideal would be to send me mails. There is also one more mail ID. I will try and say it. You can note it down. js@primemover.co.in. JS for J Srinivasan. js@primemover .co.in. So thank you for this opportunity once again, Dr. Sanjay Kot. I must appreciate and thank you immensely for this opportunity given to me. It is exactly 13:14. I have taken 1.5 hours, 53 slides. Thank you, sir.
Thank you. Thanks a lot. It was excellent as usual. We'll see if any questions from the participants. So one question is on chat box, sir. Can you see it, sir?
I'm just there are 3-4 questions coming. Yeah.
Okay.
Audio slot now got. Sir, when a new energy saving solution is recommended, how we can relate to new investment? Kausik, is it? He seems to be same question. He asked the same question to Dr. Nagesh.
Another is any software for data analysis.
Sir, industry, sir, basically work on payback. They don't work on technology excellence and things like that. You can't motivate them by saying that they will get a reward or award or anything like that. Their reward they want to calculate in the form of investment vis-a-vis the payback, return on investment. So we have, even for motors, we have ROI, net present value, and so on and so forth. I can share those slides. I have not done that here. So if you're interested, we can think about it. Any project that you take, Mr. Kaushik, I hope it is Mr. Kaushik, please always remember that the industry is motivated only on the basis of ROI. Right. Voltage unbalance and voltage variation are different in study. Does voltage unbalance mean among phases? Yes, it is among phases. My request is please read IS 13529. There is a full page dedicated to how to calculate voltage unbalance. That is when I realized that most of the people must be wrongly calculating voltage unbalance. I'm not going to elaborate on this. Please read the book IS 13529. Free download. It's a decontrolled document. Read it, you will understand. Any software for data analysis in case of energy audit, any software, no. Pradeep Chindi, sir, please, you are from the institution, develop a software yourself. Everybody will try and have a software by his own self. Software is very difficult to generally create for everybody. I think I have answered all the questions in the chat box. Unless people want to talk to me, I will take questions.
Even sir, we'll request that
I lost the audio. Hello? People are hungry, already eating. Hello? I lost the audio. Did I lose the connection also?
We are hearing, sir. We are able to hear you.
Okay, okay, good.
anybody want, they can unmute and they can talk, ask questions also. Anybody want? Directly they can ask any questions.
Actually, I almost behave like a parent to a student. Maybe my fault. Only the parents will keep telling the students, children, read, study at home. So more or less, I also said, these are all the numbers. Please go and study. All the slides that I use today, as you people must have noticed, are primarily commentaries. My objective was to help you or goad you into seeking out these documents and reading and enlightening yourself. I never said anything, as a proof. Even case studies, if you noticed, I had given only 1 or 2 case studies only, not more. You are different kettle of fish. You are different kind of people. You are people who would go and elaborate, and you are the ones who are teaching the next generation engineers. And therefore, I was particularly keen on seeing that you go and seek out these documents and read. And in that sense, I am also not going to be enthusiastic about receiving a lot of questions from you now. I expect that you will have time to read, understand, digest, and then maybe form questions, ask me in the mailbox, or follow me in the LinkedIn, so that we can have more expansions of our knowledge and understanding. So I'm not particularly keen that you should ask questions. I assume that you have understood most of what I said, or whatever I said was very, very elementary. So these are the 2 assumptions I will make at this time.
So will you be able to give us the access, sir, of the slides?
PPT, just now I'll share it with Mr. Khade and Mr. Dr. Sanjay, because I have both of their mobile numbers. So in a few minutes I will share.
We'll put on the WhatsApp group, our group. We have found one group where we'll put all the details.
Thank you very much.
Brilliant.